Hi everyone, welcome to the CS Classroom. Today we're going to talk about databases and how we can use databases with Python. If you don't have much experience with Python and you have no idea what databases are, this tutorial is perfect for you. If not, hopefully this is a useful refresher and you can still pick up some stuff you didn't know before. Let's get started. So, a database is a file or software program that allows us to store data and retrieve it even after closing our application. So especially if you're new to Python, the only way you probably know how to store information is in arrays or variables. And once you close a program, all of that's gone. A database allows us to save some information, close our program, open it back up, and still be able to access that information. Even more than that, we can use things called queries to access specific pieces of information in our database. The way that we can write these queries is using a language called SQL. And we're going to learn more about SQL and how we can use SQL from within Python in this tutorial. So let's talk a little bit about how databases are organized and what databases really are. So we know databases can be files, or they can be software programs. Regardless of which one they are, all databases have things called tables in them. So here we have a table called movie, a table called star, and a table called role played. Tables are basically different collections of specific types of information. So for example, right here, we have a collection of information related to movies. Here we have a collection of information related to film stars. And here we have a collection of information related to the role played by different characters. In each one of these tables, we have things called records. So the first record here is the first row. And it has a movie ID of M1, a title of Castaway, and a rating of PG-13. So each table will have one or more of these different records. These are just different pieces of information. Also, in each table, we have things called fields, movie ID, title, and rating. These are the specific types of information that each record will have. So each record in this table will have a movie ID, a title, and a rating. In reality, when we start talking about databases, certain fields are optional and certain fields are mandatory. So for example, we could have movie ID and title be mandatory, so every record needs to have these, but rating is not mandatory. So for some of them, it might be blank. It's optional. So to review, each of these are records. They each have different pieces of information according to the fields in a table. Each table also has different fields. These are the fields. One thing we'll talk about in another slide is also the fact that each of these fields can have different data types. So right here, from like movie ID is text, the title is text, and the rating is also text. We can also have numbers, we can have decimals, we can have booleans, and when we create our tables in our database through Python and SQL, we can specify what those are going to be. So here's a good example of how we're going to be using SQL. Right here, we have a SQL statement and this SQL statement has the keyword insert into, which means we're going to add something into the table called movie. So we're going to add a new record, and it's going to have a movie ID, a title, and rating. And that movie ID is going to be M4, the title is going to be Inception, and the rating is going to be R. So basically, if this were a real table and a real database, then right here we would have M4, we would have Inception right here, and we would have R right here. So we'll be using SQL queries like this from within Python to add data to our database. So to get started with the SQLite database, we need to create a database file. So SQLite isn't a program by itself, but when we use SQLite, we are inserting data into a file that acts as a database. So for example, right here, we're going to be working in REPL-IT, and we need to go ahead and create a file called companies.db. And that's just going to be a blank file. So to create our database, we just need to have the prefix.db, companies.db. And we need to put that in the folder in which we are executing our code. So basically where our project is. So now that we've created our database, the first thing we're going to do is we're going to create a table in that database. And we're going to have to write some code to do that. The first thing we're going to do is we're going to have the import SQLite3 line. So what we're doing is we're working with what's called a SQLite database, a particular type of database. And we need to import code so that we can work with that. The second thing we're going to do is we're going to create a connection to that database. So we have SQLite3.connect, and then we have the name of our database. So we have this connect function that's creating a connection to the database, and it's storing the data associated with that connection in a variable called con. We'll use con later on to execute queries and later on to close our connection. And then we have a query. So this query is written in SQL, and it's a command that we're going to send to the database. In this case, to create a new table. So we have the keyword create table. The name of the table is company, and we have 4 fields. We have a field called name, which is going to have a data type of text. We have a field called age, which is going to have a data type of int, which is just whole numbers. We have a field called address, which is going to have a data type, well, it's going to be 50 characters. And then we have a field called salary, which is going to have a data type of real, which just means decimals. These two also have not null, so that means that they're going to be mandatory. So every time you want to create a record, we're going to have to include a name and an age. So right here, we're creating our connection, we're writing our query, we're executing our query. So we're sending our command to the database for it to be executed. And then we're closing our connection with the database companies.db. So let's go ahead and let's execute this code. So right here we've got main.py. We've got the same code you saw before. We're going to work in the shell, and let's execute in Python main.py. And we don't have any output, which means that everything is probably fine. Everything worked. Let's see what our companies.db file looks like now. So right here we just have a huge mess of just question marks, but we do have some clues that can tell us that our code worked. For one, right here, we have the structure of our table. So now that we've created a table, let's go to our next logical step, which is inserting data into our table. So the way we're going to do this is we are going to, again, import the library SQLite3. And then we're going to create a connection we're going to create a connection to the database companies.db. And we're going to do this pretty much any time we try to run some code. Now we're going to write a new query with the keyword insert into and the name of our database. And then we're going to have each of the fields for which we want to put data into the database. So really we're making a new record here with a name, an age, and an address. And then after values right here, we're going to specify what specifically you want to put in that record. So we're going to create a record in the database with a name of Paul, an age of 32, an address of California, and a salary of 20,000. So again, just to recap, insert into keyword, name of the table, which is going to be company. Sorry, I might have said database before. Name of the table. Which fields we're going to insert values for. So this means we're going to insert a name, an age, an address, and salary, and then the actual data. Our second example right here is kind of to show how we can put Python and SQL together. So we have an array, company5 array, with a myth, a name, 28 an age, Kyrgyzstan, an address, and then a salary of 100,000. So right here, we're going to start our query just as normal. Insert into company, name, age, address, and salary. Remember, we're always going to need name and age, but these are optional. But anyways, we're going to insert all four. And then where we had values here, we're instead going to have question marks. So this question mark is going to correspond to a name. This is going to correspond to an age. This is going to correspond to an address. And this is going to correspond to a salary. Then we're going to close our quotes right here. And we're going to basically put in the values that match up to these question marks. So basically that means company 5 array 0, or a myth, is going to match up to the first question mark. And that's going to be name. Company 5 array 1, which is 28, is going to match up to the second question mark. And that's going to be the age. Company 5 array 2 is going to match up to the third question mark, and that's going to be Kyrgyzstan. And then company 5 array 3 is going to match up to the fourth question mark, and that's going to be 100,000. So basically the question marks, so whatever order we put things in here, that matches up to the equivalent question mark here. Then we're going to have the command commit, and we're going to use commit every time we want to make changes to the database. So anytime we want to insert something, we want to edit something in the database, or we want to delete something, we're going to use con.commit, and then we're going to use con.close to close our connection to the database. So this one will only have when we're making changes. This one will have it pretty much every time to close the connection to the database. So let's go ahead and run this code and see what happens. So insert example.py. So right here we have the same code you saw before. We've obviously got this. You've seen this, and you've seen this. Well, this part right here. But we have 3 extra queries just to make our database a little bit more interesting. So let's go ahead and run that. Okay, and there's no output again, which is a good sign. That means nothing went wrong. Let's go to our database and let's see if there are any clues as to whether this worked or not. So we're going to scroll all the way through our database, and if we get to the end, we can see some of the information that we entered, not all of it. We don't need to be able to see all of it, but this is a good clue that everything pretty much worked. Next, what we're going to do is we're going to confirm that it worked by retrieving data from our database. So by getting this data back. So the way this works is, again, we have this, importing library, initiating connection, but we're going to have a different kind of command. So this SQL right here is going to start with select, and then we're going to have the data that we want to get back for each record. So this means that for each record in our database, and by records, just to clarify, I mean all of these things right here that we put in, we want to get a name, an address, and a salary. So select name, address, and salary from the table company. And what this is going to do when we execute this is this is going to return an array of what are called tuples and store it in a variable, which is cursor in this case. So tuples are basically like arrays. If you want to know more information about tuples, you're going to have to go ahead and Google that because it's kind of out of the scope of this video. So to access the data in cursor, which is an array of tuples, we're going to use a for loop right here. So this is a very basic example of how you can access and how you can retrieve stuff in databases. Here's another example that kind of puts it together with Python again. We have a variable called salary upper limit equals 20,000. We have a query that selects name from company where salary is greater than question mark. And if you remember how question marks worked from our last example, this means that we can enter some data into our query. And so we close the quotes right here, and then we have parentheses and then the variable salary upper limit. So that means that this query is really going to be select name from company where salary is greater than 20,000. And that means we're going to get the names of all people from the company table who have a salary greater than 20,000. So if we go back to our queries, or if we go back to our insert Python file, Paul is a salary of 20,000, so we're not going to see him. We're not going to see Alan. We're not going to see values, but we are going to see Mark because he has a salary of 65,000, and you're going to see me because I have a salary of 100,000. Or you're going to see Amit, who has a salary of 100,000. So let's go ahead and run this code, and let's see what happens. So right here, we're going to have Python retrieve example.py. Let's go ahead and run that. Cool. You got some output right here. So this part right here corresponds to this bit of code right here. So right here, we have select name, address, and salary. So we're just showing the name, address, and salary for each record that's in the table. Next, right here, as we said, we're just showing the name for those whose salary is greater than 20,000. So, as we said before, we've got Mark and Amit right here. This is a special piece of code that we didn't see in our example. So right here, we're selecting row ID. And row ID is a field that automatically gets created that acts as an ID number for every record that we've put into the database, or into the table rather. And then we have star. So when you have star, that means that we're going to get back the data for every single field. So here we're just getting name, address, and salary. Here we're getting name. Here we're going to get everything. We're going to get name, age, address, and salary. And along with the row ID. So this lets us get the row ID, and this star lets us get everything else. And I kind of just had us print the row, so you can see what that looks like. Again, this has parentheses right here, which indicates a tuple. So our code did pretty much everything we wanted it to do, and it shows that we were able to successfully insert this data into our database. Now let's talk about how we can edit some of this information. So right here, same as before, we have the keyword update, name of the table, and then what we're going to change. So we're going to set salary to 225,000 where row ID equals 1. So if you remember where from our previous example right here, we use where to set some criteria for our actions. So here we wanted to just get names for those whose salary was greater than 20,000. So if they met this criteria of their salary being greater than 20,000, we would do this. Here, we just want to update the salary for those whose row ID equals 1. So right here, remember these are row IDs. So that means that we are going to, that means for row ID 1, which is Paul, we're going to update his salary to 25,000. So we're going to give him a raise. In our next example, again, we're putting together Python with SQL. We have update, name of the table, set salary, question mark, and then row ID question mark. And after that, we've got our parentheses. And because salary is first, that's going to correspond to the first question mark. Because row ID is second, that's going to correspond to the second question mark. And row ID was set to 2, and salary was set to 30,000. So that means that we're going to set a salary of 30,000 for anyone who has a row ID, or for any record where there is a row ID of 2. So Alan had a row ID of 2. So we're basically going to double Alan's salary to 30,000. And then because we're making a change to the database, we're going to have con.commit, and then we're going to close the connection. So let's go ahead and execute this code and see what happens. Go ahead and clear this out right here. We'll go to edit example. So right here, we've got all the same code we just saw. We're going to show the total number of rows updated. And then we're going to print out all the records, so all the names, addresses, and salaries in the database, just to show you that these queries worked. So let's do Python, edit example.py, and cool. So basically what happened, we have an extra query in here. Let's get rid of this. And let's go ahead and run our code. Okay, so basically we can see right here that Alan's salary got changed to 25,000, or sorry, Paul's salary got changed to 25,000, and Alan's salary got changed to 30,000. So we had some code before that I got rid of, and that actually made a number of significant changes. So let me show you that code again. What this did is this set everyone's salary to 30,000, where it was initially less than 35,000. So let's kind of change this to show you something a little different. So right here, everyone's salary is higher than it was before, right? Especially these guys. So let's say that everyone's salary. So for everyone who has a salary greater than 40,000 or less than 40,000, we're going to make their salary 60,000. So we've already made the changes for these queries, so nothing's really so that's not really going to matter. And anyways, all of these guys were under 40,000, so they're going to fall under the criteria for this query right here. So what we're going to do now, anyone who has less than 40,000, so these guys, their salary is going to get changed to 60,000. So let's go ahead and run that and see what happens. Cool, and it worked. These guys are all at 60,000. So lastly, let's go and see how we can delete some values from our database. Cool. Okay, right here, you've seen this before. We're going to go straight into a Python example. We have row ID equals 2. We have the keyword delete, name of the table, and a criteria. So delete from company where row ID equals question mark. And matching the question mark, we have this row ID variable, which is just 2. So in reality, delete from company where row ID equals 2. And we're making a change to the code. We're making a change to the database, rather. So con.commit, and then we're going to close the connection. Let's go ahead and execute this code. Clear this, Python delete example.py. Cool. So we had row ID 2, which was Alan, and we can see that Alan is gone. Just to make it clear, let's change the row ID right here to 3. Now let's change the row ID to 1 rather. So if you remember, row ID was automatically assigned to each record. So this is row ID 1. We got rid of row ID 2 in our code. This is probably row ID 3, row ID 4, and row ID 5. So this is going to be row ID 1 because it's the first record. Let's go ahead and run this command again, and let's see if we can't delete that. So that's going to be Paul. Okay, and Paul's gone. So those are some examples of the most basic possible functions of the SQLite3 database in Python. I hope this was useful. If you're more interested, there are a lot of resources online. We explored the concept of databases, of using databases of the programming language and SQLite at a really, really low level, at a surface level. So if you're interested in building a large-scale application, you're going to need to do a bit more research. In an upcoming tutorial, we will explore how to use SQLite with a Python GUI-based application. So stay tuned for that. I hope you enjoyed this tutorial. Have a nice day.